Hello students. So we have just completed the third unit of the first chapter, indices. Now we come to the fourth unit of the first chapter, ratios, proportions, indices, logarithms. It is placed fourth, okay, that is after indices. But actually if you get into the technicalities of logarithm, it should have come before indices because the base of indices come from logarithm. But then let's not get too much into technicals. We will stick to academics. We will see what is required from this chapter, what we learn from this chapter, and solve few problems in logarithms. If I had to give you meaning, if I have three terms, a, x, and n. I have three terms, a, x, and n. Okay, expressed as a to the power x equal to n. A to the power x equal to n. What is this equal to in terms of logarithm? I can write this as logarithm of n to the base a equal to x. Now let's see what exactly is happening. I'll start highlighting using different colors over here. First, you see this base in the exponential form, a, base in the exponential form that has moved to base of logarithm form. Correct? Okay. Next, we'll see where this x has gone, which was there in the power. It was there in the power. Now it has gone as the answer for logarithm. That's why I said it is always one step behind indices. Indices is basically about powers. Here we are getting that only as the answer. Like, how did I get that power? And the last one we have the n. Okay, take a different color. We'll go for yellow. See this n, what I'm highlighting now, has come inside logarithm. When I take the answer of exponential form, I'm finding out why we got that answer. That is, we are taking logarithm of that number, we get the answer. I told you, we'll not get too much into technicalities, we'll stick to academics. Now I'll take one number just to understand this exponential form to logarithm form. Couple of examples. This is exponential form, this is logarithm form. I can have the small table. Okay, we'll take the simplest one, 2 to the power 3. How much is that equal to? 8. 2 to the power 3 is equal to 8. If I have to express this in logarithm form, logarithm of, what do I do? 8 to the base 2. Logarithm of 8 to the base 2 is equal to 3. Take one more example. Let's take 5 to the power 4. How much is 5 to the power 4? 5 square is 25. 25 square is 625. Now if I have to write it in exponential form, logarithm of how much? 625 to the base 5 is equal to 4. One last example. Okay. We will take 3 to the power 6. How much is 3 to the power 6? 729. Correct? 729. So we can write this as logarithm of 729 to the base 3 is equal to 6. So I hope it's clear to you like how to convert exponential form to logarithm form. If you want from logarithm form to exponential form, it's just the other way around. Let me just repeat that. The base of the exponential form becomes the base of logarithm form. The power goes outside. That x which was there, it has gone outside. We are getting that as the answer. And then that n is what we are taking logarithm of. So in exponential form, that is in indices, we add some laws, properties. Basically, I call them as formulas. Here also in logarithm, the same will hold good, but then it is just written in a different way. Actually, if you see, it is same to same, but then it will look different. Let's see what they are. Laws and properties, I call them as formula only or formulae. First one that we have is logarithm of m to the base a. Logarithm of m to the base a plus logarithm of n to the base a is equal to log m n to the base a. You see the powers, you just see the powers of exponential form. Where did we have this? M plus n. When we had product having same base, correct? That is, if at all I add a to the power m into a to the power n, I got a to the power m plus n. Correct? So forget about the base over here. M plus n was there. When did we get? When we add a to the power m into a to the power n. That's how you get it. But then we don't have to relate it so much. It's okay. We will remember the formula. Log m plus log n is equal to log m. So while adding two terms of having logarithm, log m plus log n it was, we got to multiply those two numbers, right? Logarithm of mn to the base a. So if you have to take difference, logarithm of m minus logarithm of n, remember the base should be same, then we will have to divide those two numbers, m divided by n, and we get logarithm of base a only. For the first two, let me give an example. Okay, if I write log 3 plus log 2. Log 3 plus log 2. How much is this equal to? Log 3 into 2, log 6. Now if you see, I have not written the base. If I do not write the base, it is understood it is base 10. Let me write that. If base is not mentioned, then it is base 10. It's always base 10. We have base e also, that I'll teach you when we reach calculus, that is differentiation integration. For now, we will take base 10. Okay, then second one also I will give an example. Logarithm of 20 minus logarithm of how much? Let's say 6. Then what would be the answer? Log 20 by 6. I'm not going to simplify this. Log 20 by 6. I hope this much is clear. That is, when you have to add two values having logarithm, then we just have to multiply those two numbers. But remember, the base should be same. And when you have to take difference, we have to divide those two numbers. But remember, base should be same. Moving on to the third one, third formula, logarithm of m to the power n to the base a. Then what happens? The power comes outside, n log m to the base a. For example, if at all I have, let's say, logarithm of 8, logarithm of 8 to the base 2, logarithm of 8 to the base 2. You may ask, where is the power over here? I know, I intentionally kept it that way. We can rewrite this 8 as logarithm of 2 to the power 3 to the base 2. 2 to the power 3 to the base 2. Get 3 outside, you get 3 log 2 to the base 2. 3 log 2 to the base 2. We can simplify this further, but for the timing, I'll keep it as it is. I will show what can be done little later. I hope this is clear. We have brought 3 outside. Logarithm of 2 to the base 2 are left as it is. Next, we have logarithm of 1 to the base a equal to 0. Now here it is very easier for me to explain the logic behind this. See, if I have to convert this to exponential form, what happens? The base of logarithm becomes base of exponential form, correct? And this answer that you have in logarithm goes to powers. So we get a to the power 0. What is a to the power 0 equal to? Anything raised to the power 0 is equal to 1, correct? So in logarithm, logarithm of 1 to any base, logarithm of 1 to any base is 0. So I can say logarithm of 1 to base 7, answer is 0. Or one more example, logarithm of 500 to the base, logarithm of 1, logarithm of 1 to base 500 is also equal to 0. So it does not matter what the base is when you are taking logarithm of 1. Next, serial number 5, we have logarithm of a to the base a equal to 1. Same over here also, we'll try to convert it to exponential form. If at all I have base over here a, I raise it to the power 1. If I raise it to the power 1, anything raised to the power 1 is itself, correct? So we get back a. So if I write logarithm of 5 to the base 5, that is equal to 1. Logarithm of 9 to the base 9 is equal to 1. Correct? Okay. Now I'll go back to that serial number 3 where I had given example. I had 3 into log 2 to the base 2. Correct? What is log 2 to the base 2 equal to? I'll write it in a different color. If I have to simplify it, I have 3 into log 2 to the base 2 is equal to 1. 3 into 1 is equal to 3. Coming to the last one, logarithm of a to the base b. Now if I want to change the base, then I wrote log a by log b. Base is not mentioned. You can take any base, it will still hold good, but I will consider it as base 10. So if I have log a to the base b, I can write it as log a divided by log b. One example, log 7 to the base 2. What is this equal to? Log 7 divided by log 2. That's it. You need to remember these 6 formulae. They're actually laws and properties. Okay, but we'll call them as formulae because this is what we need to remember from examination point of view. This much, if you remember, I think 70% of logarithm is done. Now you'll ask me what about the remaining 30%? We'll see that. I'm telling you, most of the questions we can solve it in a different method. From academic point of view, actually as per syllabus, this is all that is required. But I will teach you one calculator shortcut. Remember the calculator shortcut I taught you in indices, where we have to take nth root of a particular number. Correct? Something similar like that, I will teach you even in logarithm. So how do we do that? First, I'll write down the formula, then I will explain using some numbers. Now, this formula, this is calculator shortcut, can be used only when we have base 10. Remember this can be used only if you have base 10. So, if I have to find logarithm of a particular number, let's say x, logarithm of a particular number, let's say x, I will specifically write base 10 over here. Actually not required because I've already told you if I do not mention the base, it is always base 10. But then here let me write that as well. This is what you need to do in your calculator. Okay, you need to press this number, that number for which you have to find log. First, in the calculator, press square root 13 times. Press square root 13 times. Then minus 1 into 3558. That's it. You need to remember this. Memorize, by heart, call whatever you want. Just remember this. Logarithm, also obviously after that you have to press equal to get the answer. So we have to press x first, square root 13 times minus 1 into 3558. Now we have to check this. We should not blindly believe everything that you see. Okay. So we need proof. So we'll take a number for which we know the answer. That is logarithm of something for which we know the answer. Remember in the previous slide I told you logarithm of 8 to the base 2. Logarithm of 8 to the base 2 is equal to how much? 3. Correct. This is what I had done earlier when I was explaining laws and properties. Logarithm of 8 to the base 2 is equal to 3. Now in the calculator, what do I need to do? Press 8 in your calculator. 8 in your calculator. Stay with me. Press square root 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Something is there on the screen. I am not going to bother about it. Minus 1 into 3558. After that, press equal to. You get the answer as 0.9032. But then I told you will get the answer as 3. So where did I go wrong? Yes, I told you we can use this formula only if you have base 10. Correct? But what I did was, this is for base 2. So how do I convert this now? How do I convert something which is of base 2 to base 10? So I'll keep this answer aside. Remember, that is for base 10 only. So log 8 to the base 2. The last part of the previous slide, I told you we can change the base. If I have log 8 to the base 2, I can rewrite it as log 8 by log 2. Correct? I can rewrite it as log 8 to the log 2. Now both are base 10. Now the answer that I got is over here. So because we were checking, we Got to know, okay, we have gone wrong somewhere. So we will remember this forever now. That is, we can use this only if it is base 10, not otherwise. Now separately I need to do log 2. Again, let me try it in the calculator. Press 2 in your calculator. Press square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 1 into 3558 equal to, you get 0.301 3011. Now if you simplify these, you get answer equal to 3. Then you get some decimals. That should not be a problem for us, because you know the two answers will not be that close. You'll not answer like 3 and then 3.0001. Okay, that's the difference that you will get. So don't worry about it. Answer is 3. Let us take one more example, but this time we will start from scratch. We'll start from exponential form, because we should know the answer when you're using shortcut method. Like, at least till we get comfortable, so we'll know where are the places where we'll go wrong. So we'll take a number in exponential form. I will take 7 to the power 5. 7 to the power 5. First we'll take the answer. How much is this? Let's try. 7 square is 49, cube is 343, raised to the power 4, raised to the power 5. I get the answer as 16807. 7 into 7 into 7 into 7 into 7 in your calculator. 7 double into equal to equal to equal to equal to. So we get 16807. Now we'll convert this to logarithm form. How do we do that? Logarithm of 16807 to the base 7 is equal to 5. That's done. Okay. Now I'll use shortcut method and I'll see if I'll get right answer. My answer should be 5. Remember, my answer should be 5. I'm taking logarithm of 16807 to the base 7. Correct? Okay. In your calculator now, first press 16807. Press square root 13 times minus 1 into 3558. Remember, you have taken logarithm of 16807. What more do we need to do? Divided by, we need to press 7 square root 13 times minus 1 into 3558. What did I do? I got the answer first. Now I'll write why exactly I did this. What is the reason? Because we have to convert it to base 10. So I'll rewrite that. Logarithm of 16807 divided by log 7. Now this is equal to your final answer. I have also written what exactly is supposed to do in your calculator. I'll repeat again. This can be used only if it is base 10. So I have to convert it to base 10 first. Log m to the base n is equal to log m divided by log n. Okay. Now in the calculator, 16807 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3558. I get 4.228. Okay, now I'll do the denominator. 7 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3558. I get 0.845. Okay, then I will divide. I get 5.002. Ignore this. Answer is equal to 5. So we can use this in all the problems, most of the problems for that matter. I think at least 50% of the questions that I'm solving will do it in this method only. Other methods can be followed if you're comfortable. If you have done logarithm before, then you can definitely follow these methods. Otherwise, to get answers from exam point of view, we can use this. Remember the steps. First step, convert it to base 10. Always convert it to base 10. Any number you can convert it to base 10. Once you do that, you have to use calculator shortcut, square root 13 times minus 1 into 3558. And then if there is simplification, you need to do that. I hope this method is clear. Let's see how we can use this method as well as laws and properties in the problems. Coming to the first question, logarithm of 6 plus logarithm of 5. Logarithm of 6 plus logarithm of 5. Okay. It is in the form of log m plus log n. We know that it's the first question, so let me write that. Logarithm of m plus logarithm of n is equal to log m n. Now replace, we have logarithm of 6 plus logarithm of 5. 6 into 5. 6 into 5 is how much? Logarithm of 30. Answer is B. Yay! Easy, right? Isn't it? We simply thought logarithm is difficult. It is not. Properties, laws. How many points should I give? I give you just 6 points. Correct? Yes, this one. After that, I gave you the calculator shortcut method, and I have not used that yet in the problems. This problem, we directly use log m plus log n. Okay. We'll move on to the next question. We have log 8 to the base 2. I've already explained this. We did it enough number of times. First, I took it in the example, and then again, that was used for calculating using calculator. Okay, so the answer is 2. Answer is 2. We'll move on to the next question. Question number 3. We have value of, see, some decimals are there. We have logarithm of 0.0001 to the base 0.1. Now when we have problems like this, some of you, it will flash right up. Okay, I can write this as logarithm of 0.1 to the power 4 to the base 0.1. It will flash. If I have to continue, let me continue and get the answer. 4 comes outside because we have log m to the power n is n log m. So we have 4 log 0.1 to the base 0.1. And then we have 4 into log 0.1 to the base 0.1 is equal to 1. Answer is equal to 4. If it comes to you, great. The reason why I went fast is I am going to still go by calculator method. We'll change the color to red for calculator method. Fine. What do we need to do in the calculator? Step 1. I have to convert it to base 10. Correct? So we have logarithm of 0.0001 divided by logarithm of 0.1. I've converted it to base 10. Now in the calculator, numerator I will do it separately, denominator I will do it separately. Numerator, in fact I'll start with the denominator because I can use memory functions. 0.1, okay. Square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times I pressed minus 1 into 3558. Actually, I don't need to write down this answer because I'm using memory functions, but then just so that you are also in the same page, I'm writing this. My answer is negative 0.9999. Correct? Okay. It's almost equal to 1, 0.9999. Now I'll clear my screen in the calculator. Now I have 0.0001. Okay, square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3558. I get 3.99, which is again negative 3.9980. Correct? And now if I divide this, I get answer equal to 4. Very, very close to 4. Some decimal differences you get. That is not a problem. When you use memory functions, first if I do denominator, I'll keep it as memory plus, okay. Then I'll do the numerator divided by MRC. Divided by MRC, memory recall, we get the answer. Answer is equal to 4. If you're finding memory functions difficult, no problem. Do numerator separately, take 4 decimals, otherwise we may get a wrong answer. Then do denominator, take 4 decimals, and then simplify, you get the answer. For the ones who are comfortable with the actual method, which is written in black, you can go ahead with that. You'll get same answer. Answer is 4 by either of the methods. Moving on. Question number 5. We have 2 log x equals 4 log 3. Just rewrite that. Okay. 2 log x equal to 4 log 3. We have to find the value of x. Okay. Can I just cancel log and log, saying that 2 into log into x, 4 into log into 3? No. Remember, for cancellation of log, what we actually call as anti-log on both sides, you should have you should have no coefficient or coefficient equal to 1. That is, before log, prefix for log should be equal to 1 or nothing. If you don't write anything, it is understood it is 1. 1 into anything is 1. Can we use that over here? No, because for first one on the left hand side, we have 2. We have 2. What am I highlighting now? Okay, we have 2. And for the right hand side, we have 4. Yes, we can simplify, but then here I will avoid simplifying. What we'll do is we will take it inside over here as powers. How did I get this? We have logarithm of m to the power n is equal to n log m. Correct? But here it is in the form of n log m, so we are converting it back to logarithm of m to the power n. Correct? So after taking it in powers, we get log x square equal to log 3 to the power 4. Now if you see on left hand side and right hand side, we don't have anything before logarithm. Correct? Okay. So we can take anti-log on both sides. I will write it as anti-log only. Okay, anti-log both sides. I have told you multiple times, whatever you do on one side, same thing should be done on the other side. You can add, subtract, multiply, divide, square root. We have done all of this in the first 3 units, and here we are taking log, anti-log. Log we are not taken yet. Anti-log we are taking both sides. Okay. So log cancels. When you take anti-log, you get x square equal to 3 to the power 4. What is 3 to the power 4? 3 into 3 is 9. 9 into 9 is 81. And what is x equal to? Square root of 81. How much is that equal to? That is equal to 9. Answer is 9. I hope it's clear. Slightly different from what we did earlier. Here, we have to take it inside. Correct? Okay. So we have to use log m to the power n equal to n log m. Once we got it in terms of exponential form inside the logarithm, then we could take anti-log, simplify, get the answer. Correct? Okay. We'll move on to the next question. Question number 5. Logarithm of 64 to the base root 2. So if you use the regular normal method, we would have to express 64 as something root 2 to the power something. Because then we can use that log m to the power n and get the answer. Like I told you in that one problem where I solved it in both the methods. Let me just take you back over there. Yes, here, this problem. Correct? So we always have to express that number, the given number for which we have to find logarithm as in terms of log. I mean in terms of base. But then it won't come naturally to everyone. Some of you may get it. Okay. 64 is a perfect number of 2. If it's a perfect number of 2, then obviously we can express it as root 2 also. But then no, we will think that we are coming to this chapter not having any information about log. We are starting from scratch. We will use shortcut method only. I will take this as log 64 divided by log root 2. Log 64 divided by log root 2. I've just expanded it in terms of base 10. Now 64 and base root 2 is there. So in your calculator, we'll start from the denominator. Correct? We are using memory functions this time. Okay. First we need root 2 ka value. So press 2 and press square root. On your screen right now, you have 1.4142135627. That's the number of digits I have. Okay. You have this in your calculator. Now you have to press square root 13 times. You already pressed once, don't include that. That square root was just to get the value of root 2. Now press square root 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Minus 1 into 3, 5, 5, 8. How much is this? I actually don't have to write, I told you. I'm using memory. But it's okay. We'll write over here. I have also pressed m plus in the calculator. Now don't press on, cancel anything. Directly press 64. Square root 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 1 into 3, 5, 5, 8. How much is that? 1.8068. Correct? Okay. I've taken 4 decimals. Now what you have on screen is the numerator. Press divided by symbol. Press MRC. And then press equal to. You get answer as 12.002795. I use memory functions. Or let's say you're finding memory functions difficult. I would suggest you to practice memory functions. But if you still find it very difficult, write it down like I have written. You'll get the answer as 12 only. Do we have that in the option? Yes, for sure. Option A is the right answer. Answer is 12. Also, if you're going with the regular methods, let me do that also. You could have written logarithm of 64. 64 is 2 to the power 6. If it is 2 to the power 6, it should be root 2 to the power 12. Oh, now you think, oh, this was also easy, right? So then 12 comes out. Logarithm of root 2 to the base root 2. This becomes equal to 1. Answer is 12. Whichever method you are comfortable with. Moving on to the next question. We have logarithm of 1728 to the base 2 root 2. First step, we will rewrite the given question as base 10 logarithm of 2 root 3. I'll show one extra step over here because some of you will not get the value of 2 root 3 first, and then you have to press again square root 13. It can be confusing. Numerator is not a problem, so I'll write that as it is. Denominator, okay, 2 root 3. First press 3 in your calculator, press square root. Okay, you get 1.73205080. That value you have in your calculator into 2, you get 3.4641. Just to make sure you got it right up till here. From here it is same. I already have it in my calculator, so I'll start from the denominator again. Square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 1 into 3558. I get 0.5397. For now, I'll keep it in the memory. It's written over here, but I'm directly doing it in the calculator. I kept it in the memory. Now come to numerator 1728 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 1 into 3558. I get 3.2392 divided by MRC equal to, I get 6.002. Ignore that, answer is equal to 6. Ignore after your first decimal, two answers will not be that close. Do not worry, you get answer as 6. Now if you actually think, you can write 1728 as 2 root 3 to the power 6. Now I'm going to show it in that method now. I'm sure you're comfortable with this method. And even if I do it in that method, you must have figured it by now after you got the answer. We'll move on to the next question. Question number 7, a slightly different question. We have a logarithm of, I'll rewrite that, logarithm of 16 to the base 2 to the base 2 to the base 2. Correct? Okay. Here, if I do the last part first, 16, then I have to press square root 13 times minus 1 into 3558, then divided by base 2, no? So 2 square root 13 times minus 1 into 3558. It gets very lengthy. See, my main logic of using that calculator shortcut is when we are stuck and we do not know how to solve it. But here, if I use it, I'll only make my solution lengthier. Also, I have 16, ending number is 16. By now, I know that 16 is a perfect number of 2. It's 2 to the power 4. And if I can write it that way, easily I can simplify it and get the answer. So I'll go for the regular method over here. 16, I'll just highlight that this 16, this 16 can be rewritten, okay, can be rewritten as 2 to the power 4. Remaining everything I'll leave as it is. Log of 16 is 2 to the power 4 to the base 2 to the base 2 to the base 2. Again, highlight it using the same color just to show you how I have changed from 16 to 2 to the power 4. Now what is the next step? In the next step, this should come inside, right? This 4 should come inside. What is there in the power? Oh, in fact, outside. It was there in the power. It should come outside. Fine. So what do we get? I have log of 4 came out. Log to the base 2 to the base 2. Earlier one also to the base 2 to the base 2. So what is this equal to? The last part. Log 2 to the base 2. What I've highlighted now, this is equal to 1. This is equal to 1. So if I again rewrite the remaining part, I have log of 4 into 1 to the base 2 to the base 2. 4 into 1 is equal to 4. I'm not going to write one more step for that. But the next is 4 now. How do we write 4? 4 can be written as this 4. This 4 can be written as 2 to the power 2. So we are repeating the steps now. We now have logarithm of 2 to the power 2 to the base 2 to the base 2. Repeat the steps again. I'll continue on the right hand side. Okay. So get a 2 outside logarithm. So we get log of 2 log 2 to the base 2 to the base 2. How did I get that? I'll just show the arrow. This 2 that is there has come inside now. Okay. In between logs. It has come outside log. Fine. Okay. So now what is this equal to? If I use a different color for this one. Now this is equal to 1. This is also equal to 1. What is 1 into 1? 1 into 1 equal to 1. Answer is C equal to 1. So this is clear. This is one of the important questions. They keep asking this in the examination. So practice such questions. I think another 1 or 2 questions are there in the exercise. We will solve them. You will get comfortable. We use the regular method over here. Remember, when we have problems like this, the last number is always a perfect number. You can check a couple of numbers. How to get clues? See the base. So base is 2 here. So it should be 2 to the power something. Otherwise, you'll not be able to solve. Fine. Answer is 7. Answer is equal to 1. That is question number 7. Moving on. Question number 8. Value of log 1 by 3 to base 9. What changes? Nothing changes for us. We will use same method. So we have log 1 by 3. I'll write together in the numerator divided by log 9. Correct? In your calculator, start from the denominator. Square root 9 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3, 5, 5, 8. I'll write down 0.9544. Okay, keep it in memory. And then I have numerator 1 by 3. First I need to do 1 divided by 3. Do it in the calculator. Even if you know how much is 1 by 3, don't write 0.33. Because there are many more decimals after that. 0.333333333333. Correct? Then after that, square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3, 5, 5, 8. You get the answer, which is a negative 1, 0.477. Okay, divided by what you already have it in your memory. Recall that memory, MRC equal to, you get negative 0.5. You get negative 0.5. Actual answer, if you use memory, you get negative 0.499899. So you will obviously get 0.5, negative 0.5. What is that equal to? Option A, minus 1 by 2. Hope this is clear. So we are using shortcut method on the over here. Nothing changed, even though we had 1 by 3 for which we had to take logarithm. Nothing changes. We'll move on to the next question. Question number 9. If log x plus log y is equal to log x plus y, we have to find the value of y. I'll rewrite the given question. One more important question. Okay, when we have questions like this, these come in the examination also, but they are not difficult. Okay. Now, can we cancel log on both sides? No. What is the rule I told you? We should not have anything before that. We anyways do not have. But then we are having two values over here. We have log x plus log y. It's not that I can cancel it directly. So first step is where you have to use the formula, the laws. Okay. So we have log x plus y as log xy. Can I write this? Yes. Log m plus log n is log mn equal to log x plus y. Now if you see, we have log of something, log of something. Correct? Take anti-log on both sides. Anti-log both sides. We have xy equal to x plus y. From here it has got nothing to do with logarithm. We are back to solving algebraic equations. Okay? More on equations in chapter 2. But I'm sure you know how to solve for y over here. Get y on one side. Xy minus y equal to x. X is common. Factorization. X minus 1 equal to x, and y is equal to x divided by x minus 1. Do we have that option? We should, and it is there. Option C is the right answer. Moving on, we'll go to the next question. Question number 10. Value of log of 27 to the power 3 to the base 3 to the base 3 to the base 2 to the base 2. That's how you read it. I just rewrite that question. Log of log of 27 to the power 3 Okay, I think I have to write log again, right? Okay, so we'll write log again, log of. Okay, 27 to the power 3 to the base 3 to the base 3 to the base 2 to the base 2. I've expanded it nicely so that it looks clear. So we have last one ka base 3, and also I know 27 to be 3 to the power 3. So I'll write only that now in the next step. Log of log of log of log of 27 is 3 to the power 3. Only this. What I'm highlighting, 27 I've highlighted, and here I've highlighted 3 to the power 3. Whole to the power 3 should continue as it is. Correct? To the base 3, to the base 3, to the base 2, to the base 2. Done. Now simplify that. 3 to the power 3 whole to the power 3. We have learned this in indices. That is 3 to the power 9. We'll write that. Okay. Log of 3 to the power 9, remaining everything again back to what it was. Now what happens? What is the next step? Next step, this 9 that is there in power comes outside that particular logarithm. Okay, now I'll rewrite remaining again. Log of log of 9 here, and then we have log 3 to the base 3 to the base 3 to the base 2 to the base 2. Correct? Now what happens? Last that we have log 3 to the base 3 is equal to 1. From now on I'll just strike it off. That is equal to 1, and when we do 9 into 1 it is equal to 9 only. Now I'll continue. This 9 that is there, I can write it as 3 to the power 3. So I will write it as log of log of log of 3 square. 9 is 3 square. Correct? 3 to the base 2 to the base 2. Get it to outside logarithm. Okay, this 2 outside logarithm over here, and then continue again. Log of 2 log 3 to the base 3 to the base 2 to the base 2. I'll continue here on the right side. Okay, that space should be enough for me. And we can cancel off this one. We have log 3 to the base 3 cancels. We have log 2 to the base 2 also cancels. So we have into 1. Now what remains? We have only log 1 to the base 2 remaining. What is log 1 to the base 2? Anything, anything raised to the power, sorry, in fact, logarithm of 1 to any base is equal to 0. Answer is equal to 0. Logarithm of 1 to any base is equal to 0. That's it. See, what we have done over here is I've shown too many steps. It was not required. You can skip 2-3 steps in the middle and get the answer. 27 is there, base 3 is there. Express it using 3 to the power something. Then go on simplifying like we did in the other problem. It's very similar to the one which we solved earlier. We had, I think, question number, yes, 7, which was there, is very similar to that. Okay, there we got answer as 1 because last we had got a number to same base. Here we have log 1 to any base, it does not matter. Answer is equal to 0. Moving on to the next question. If log x to the base 2 plus log x to the base 4 plus log x to the base 16 is equal to 21 by 4. We have to find the value of x. One way to do this is, we'll go for trial and error. Whatever is in the option, we'll put in place of x. See if left hand side is equal to right hand side. If it is, that is the answer. Otherwise, move on to the next option. We're not going to do that. I'll show you the actual method. So if you see over here, we have log x, log x, log x, but in different bases. So my first step is change the base. So I'll rewrite the given question. Log x by changing the base divided by log 2 plus log x divided by log 4 plus log x divided by log 16. I hope you have no doubt up till here. Right hand side remains as it is. Now if you see the denominator, we have log 2, log 4, log 16, and these numbers are perfect numbers of 2. So I'll rewrite them as perfect numbers of 2. It makes it easier to simplify. So numerator remains same. Denominator for the first one is log 2 plus log 4 can be written as log 2 square. Log 2 square, correct? So log 2 square can also be written as 2 log 2. I'm doing two steps at once over here. Okay, I can make a note of that. I will show it in red over here. This 4 has been written as 2 square, and then that 2 has come outside. Okay, fine. Let's see, we have the next one. I hope to get a right answer over here. Plus log x, log 16. What is log 16 now? 16 can be written as 2 to the power 4. 4 comes outside. So 4 log 2, correct, equal to 21 by 4. This much is done. What is the next step? What did we do in other chapters where we had different denominator, but we wanted to add them? Same over here also. We need to take LCM. LCM will be 4 log 2. 4 log 2 is the LCM for all these three. Log 2 is there, 2 log 2 is there, 4 log 2 is there. Common one is 4 log 2. For the first one, out of 4 log 2 is already there. So you have to multiply with 4. 4 log x plus, out of 4 log 2 in the LCM, denominator is already 2 log 2, where I am highlighting right now, I am marking right now. Okay, so 2 log 2 is there, 4 log 2 divided by 2 log 2 is 2, 2 should be multiplied, 2 log x, I hope everybody knows LCM how it works, plus 4 log 2 is already there, so we get log x. Right hand side 21 by 4. Now if you see, there is 4 in the denominator of the left hand side, 4 in the denominator of right hand side, cancels. Remaining numerator we can add 4 log x, 2 log x, log x, 4 plus 2 plus 1, 7 log x equal to 21 is there, cross multiply log 2 goes to the other side. Correct? Further 7 goes once, 7 goes 3 times. Correct? So log x is equal to 3 log 2. How to simplify from here? Can you cancel log and log? What is the rule that I told you? When you have to cancel, you should make sure there's nothing before logarithm. Correct? Okay. So we have log x is equal to, take 3 inside, log 2 to the power 3. Further, I'll continue here. Log x is equal to log 2 to the power 3 is 8. Correct? Now we'll take anti-log. On both sides, we get x equal to 8. Is that there in the option? Yes, that's the first option. So even if you had gone for trial and error, we would have got the answer quickly because option A itself is the right answer. But I've shown you the right method as well. We need to take them as perfect numbers of 2, then take LCM, then solve like you solve without log. If there was no log, we would have normally solved, right? We would have 2, 4 and 16, and then we would have taken LCM, all of that. So same to same thing we will do over here, but the problem over here is we had log, so we have to make some adjustments in the beginning. We'll move on to the next question, question number 12. Log 2 to the base 10 is equal to x. Log 3 to the base 10 is equal to y. Log 1.2 to the base 10 can be expressed as two ways to solve it. One, the right way, proper steps. Second, where I use a shortcut method. First, I'll go by the shortcut method to just show you how we can think differently and solve this. Okay. First, we have log 2 to the base 10, correct? I'll find the value of this. How much is log 2 to the base 10? If I do 2 square root 13 times minus 1, 3558. See what you get. I've done this multiple times, so I'll write the answer directly, 0.301. You can do it. I'll give you time. 2 square root 13 times minus 1 into 3558. You'll get 0.301. Next, you'll find the value of log 3. How much is the value of log 3? This I will do it along with you in the calculator. Okay, we have 3 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3558. How much is this? 0.477. So now I have the value of log 2. I have the value of log 3. What do we have to find out? Log 1.2. This also I will find out. 1.2 square root 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 into 3558. How much is that? 0.079. This much is enough. Once I know this much, what I'll do is I'll go for trial and error. Okay, option A. What does option A say? X plus 2y minus 1. What is x? We got 0.301. What is 2y? 2 into y is 0.477 minus 1. Let me see what this answer is equal to. We have 2 into 0.477 plus 0.301 minus 1. If I do, I'll get the answer as 0.255. But my right answer is 0.079. Wrong answer. Second option, x plus y minus 1. I don't think this is also the right answer. Plus 0.477 minus 1. This is also wrong. Option C. Option C, we have 2x plus y minus 1. So 2 into 0.301 plus y 0.477 minus 1. Let me check this. 0.301 into 2 is 0.602 plus 0.477 minus 1. If I do, I get 0.079, which is the same answer I had got earlier. Option C is the right answer. If you see over here, unlike other problems, I've solved this in red because I'm using trial and error method. This is not the actual method. The main method, I'm solving it in black now. Okay. How to solve this? 1.2. The given question is log 1.2 to the base 10. I have to express 1.2 using numbers 2, 3. Why 2 and 3? Because I know the value of log 2 and log 3. So I can use number 2. I can use number 3. Other than these two numbers, I can use number 10. Why is that? Because I know log 10 to the base 10 is 1. I know the answer of that. Log a to the base a is 1. Log 10 to the base 10 is 1. So the numbers that I can use are 2, 3, 10. And remember, you can always use 1 because log 1 to any base is 0. But for now, these three numbers are enough for us. How to express 12 now? Equal to, I'll expand 1.2. 1.2 is nothing but 12 divided by 10, correct? How to get 12 now? Using 2 and 3. 6 into 2. How to get 6? 3 into 2. So can I write this as 3 into 2, which is 6, into 2, which is 12, divided by 10 to the base 10. Correct? Okay. Now if I have to expand this, how much is log 3? Or further, I can write this as log 3 into is there. So plus log 2 plus log 2 minus, I'll move it a little bit to adjust for the space. Okay. Minus, because of division, log 10. All are base 10, so I have not mentioned. What is log 3 equal to? Log 3 is equal to y. Log 2 is equal to, which is repeated 2 times. Okay, anyways, I'll write x plus x. What is log 10 to the base 10? Equal to 1. Now I have 2x plus y minus 1 as the answer. Lengthwise, this looks much smaller, the one which I've written in black, the right way of solving it. But then sometimes it will not click to you as to how you're supposed to express 1.2. And that time we can use these methods because ultimately for me, I should get the answer. So I've done it in both the ways, whichever you're comfortable with, go ahead with that. If you're comfortable with both, definitely you should go for the right method because that becomes easier and quicker. Fine. With that, we'll move on to the next question. Question number 13. Log x is given, m plus n. Log y is given, m minus n. Then the value of log 10x by y square. Let me just expand it first without even looking into other information. Log 10x is there, so I can write it as log 10 plus log x. That became log 10x. Divided by is there minus log y square. No doubt here, log m plus log n or log m minus log n all taken together. How much is log 10 to the base 10? I just told you in the previous problem. Log 10 to the base 10 is 1. How much is log x? Log x is given, right? How much is it? M plus n. Okay, we have m plus n minus. Log y square is there, so 2 comes outside. 2 comes outside. I'll highlight that part. Okay, this 2 coming outside. After that, we have log y. Log y is m minus n. Don't write m minus n the square. Okay, first we have to bring 2 outside. Okay. Further, 1 plus m plus n minus 2 times m minus into minus will become plus 2n. Simplifying that, I get, looking into the options, I see m written first. Some places n is there. Okay, first we'll see what is m. We have minus 2m. We have positive m. So minus m we get. Where do we have minus m? Okay, in the first option. And there they have started with 1. Okay, 1 minus m. And then we have plus 3n, which is there in the first option. I just wanted the same order as that is there in the options. That's why I was looking for what is there. Otherwise, you can just solve and then you can look for the options also. I hope this is clear. We'll move on to the next question. Question number 14. Log x minus y divided by 2 equal to half of log x plus log y. Then the value of x square plus y square. Okay. From where do we start? Remember, somehow we have to cancel log. So what is the next thing that we should know? We should get everything inside logarithm. Only if you have everything inside logarithm, then we can cancel, otherwise we cannot. The rule is there should be nothing before logarithm. Everything should be inside, then we can take anti-log. Okay, so the given question, left hand side, I don't think I should simplify as of now. There is nothing outside logarithm, everything is inside, equal to 1 by 2 is outside, but then first I can simplify log x plus log y. How much is log x plus log y? Log xy. Log xy. Now I can take this 1 by 2 inside. What happens? We have log x minus y by 2 remaining in the left hand side equal to right hand side. I'll take that half inside, so I get log xy to the power 1 by 2. Now everything is there inside logarithm. I will take anti-log on both sides. Basically cancelling logarithm. So I cancel log. So I get x minus y divided by 2 equal to xy raised to the power 1 by 2. How to simplify further? We have raised to the power 1 by 2. That is nothing but square root. How to cancel square root? We need to square both sides. Square both sides. We have done this before. Okay. So we have x minus y divided by 2 whole square is equal to xy to the power 1 by 2 square. Obviously, square and square root cancels. I'll continue here on the right side. Okay. On the left hand side, I have x minus y whole square, which is x square plus y square minus 2xy. How did I get this? A minus b whole square. What is a minus b whole square? A square minus 2ab plus b square. Same thing, I have expanded over here, divided by, denominator was 2, I had to square it. I get 4 equal to xy is all that is remaining. Cross multiply. I have x square plus y square minus 2xy equal to 4xy. Correct? 4 is multiplied. Now what is the requirement of the question? Just x square plus y square equal to 6xy. Taking minus 2xy to the other side, we get 6xy. Moving on to the next question. Question number 15. Value of 1 plus 1 by 5, 1 plus 1 by 6, 1 plus 1 by 7, and so on. It goes on and on up till 1 plus 1 by 624 to the base 5. To the base 5. Let me try to simplify this. Log. If I add 1/5 to 1, what do I get? 6 by 5. Correct? 6 by 5. Base 5 plus log 1 plus 1 by 6. 7 by 6 to the base 5. It goes on up till log 625. 624 plus 1 625 divided by 624 to the base 5. Correct, middle terms are not there. It's okay. Does not matter. Now we have log m plus log n plus log o, p, q, r, s, t goes on. It is plus sign in between, but we have log and separated by plus signs. So this will be equal to log of 6 into 5 into 7 into by 6 into it goes on and on and on till we get 625 by 624 to the base 5. Now we'll need to analyze this clearly. See, there is 6 here in the numerator, correct? It gets cancelled with the 6 in the denominator. Same way, there is 7 in the numerator and it will get cancelled to the invisible 7 in the denominator. I'm not written because it continues. If I had written, it would have been 7 there because it would be 6 by 5, 7 by 6, 8 by 7, 9 by 8, 10 by 9 and so on. So this goes on cancelling. The numerator of the one cancels the denominator of the next term. Goes on that way and at some point we'll reach 625 and 624. Which one will cancel? 624 will cancel. 625 will remain. I hope this is clear. So all the numerators will cancel other than 625. All the denominators will cancel other than 5. So what remains now is logarithm of 625 by 5. Only this much will remain to the base 5. What is 625 divided by 5? Logarithm of 125 divided by 5. Not using shortcut method over here. 125 we know is a perfect number. Okay. Log 125 can be written as 5 to the power 3 to the base 5. Further, get 3 outside. Log 5 to the base 5. 3 into 5 to the base 5 is equal to 1. Answer, final answer is 3. Final answer is 3. Moving on to the next question. Question number 16. X value is given, Y value is given, Z value is given. We have to expand now. Why? Because we have X, Y, Z plus 1. So I'll write it here. We have X, Y, Z plus 1. We need the value of this. But I write it so far because I know how to write under that. I will have to substitute it. X is how much? Log 12 divided by log 24. But it is given log 12 to the base 24. Yes, I have changed the base. Log 12 divided by log 24. What is y equal to? X into, right? X into y into z. Y is equal to log 24 by log 36. Z. Log 36 divided by log 48 plus 1 as it is. Now I'll simplify. I'll get a smaller term. Smaller terms, we have 24 24 cancelling, 36 36 cancelling. What remains now? I'll just rewrite what is remaining. I have log 12 by log 48. That's it. Okay, we have plus 1 which is remaining. Now we'll take LCM. Common denominator is log 48, log 12 as it is, plus there it was plus 1, so we have log 48. Further, we have log m plus log n, right? Log 12 plus log 48. 12 into 48. How much is that? 576. So we have log 576 divided by log 48. So much is done. We'll continue here. Okay. 576. 576 is a perfect number, correct? We know that 625 is 25 square. So we'll just check 24 square. Yes, 576. So we have log 24 square divided by log 48. equal to 2 comes outside, log 24 divided by log 48. Now we'll see the question because the answer is given in terms of x and y. Log 24 we have it in y. Log 48 we have it in the denominator of z. I repeat, I'll just highlight now. See this 24, log 24 is there here. Okay. And log 48 is there here in z denominator. It is in the numerator of y. It is in the denominator of z. So I will expand the given one. What we have got now 2 log 24. I have no option to write full log 24 by log 36. But now to cancel log 36, I will write log 36 over here divided by log 48. Any objection on this? If you see I have not changed the value at all. Now if I simplify this, log 36 cancels. 24, 48 will remain. Okay. So I have not changed the value. Now what is this equal to? Log 24 by log 36. That is equal to y. What is log 36 by log 48? That is equal to z. Answer is 2yz. Option C is the right answer. Moving on to the next question. Question number 17. If log b to the base a plus log c to the base a is equal to 0, then we have to find the relation. Now we have two terms over here. I cannot take anti-log directly. I've told you there should be just one term and everything that is there should be inside logarithm. So we'll do one thing. We will take one of the term to the other side. What do we get over here? Log b to the base a equal to, I'll take log c to the base a to the other side minus log c to the base a. Can I take anti-log now? No, we still don't have everything inside logarithm. I told you outside logarithm there should be only be 1, but right hand side has minus 1. 1 is not there, but when I say 1 minus log c, it is indirectly minus 1 into log c to the base a. So take the minus sign outside, inside. We have log b to the base a equal to log c to the power minus 1 to the base a. Now we have log, everything is inside and there is nothing outside. So we will take anti-log on both sides. We get b is equal to c to the power minus 1. What is c to the power minus 1? Indices. B is equal to 1 by c. What would that mean? B is equal to 1 by c means b and c are reciprocal. I hope that's clear. If you go for trial and error, see it looks like even C is the right answer. But the problem over there is when you have B equal to C equal to 1, if you go for trial and error, log 1 to any base is 0. So it will look like 0 plus 0, it is 0. But it need not be. So if you go for trial and error, there is a possibility of going wrong. So solve it in the right method only over here. B and C are reciprocals. What have I done over here? I wanted to cancel log and log, so I have taken one log to the other side. Then I have taken the minus sign inside as the power, so it becomes raised to the power minus 1. Once my condition is met, nothing outside logarithm, I have taken anti-log and I've got b equal to c to the power minus 1. What is c to the power minus 1? 1 by c. I've got the answer. Moving on to the next question. Logarithm of x to the base 10 minus 3. Remember, there is no bracket over here. So it is not log x minus 3 to the base 10. It is log x to the base 10 minus 3 divided by 2 plus 11 minus log x to the base 10 divided by 3 equal to 2. Step 1, we have two terms, plus sign in the middle. No points for guessing. We are going for LCM. What is LCM? 2 and 3, 6. Cross multiplication now. Cross multiplication. We have 3 times log x to the base 10 minus 3 plus 2 times 11 minus log x to the base 10. And on the other side we have equal to 2. Cross multiply, 6 2s are 12. Okay. Open the bracket at the same time. 3 log x minus 9 plus 22 minus 2 log x to the base 10 equal to 12. Take numbers to one side, remaining we'll keep it to the other side. We have 3 log x minus 2 log x base 10 I'm ignoring equal to 3 log x minus 2 log x is equal to 12 is there. We add 9 to it. 12 plus 9 is 21 minus 22 is minus 1. So minus 1 remains on the right hand side. 3 log x minus 2 log x. 3 minus 2 is only log x. So we get log x equal to minus 1. Now if I have to convert this to exponential form, how do I do it? I'll try to write this in exponential form. Remember there is invisible base 10. So what do we get? 10 to the power minus 1 equal to x. Base of exponential form is base of logarithm form. The number goes to powers, and what is the value of x? It is 10 to the power minus 1. 10 to the power minus 1 is the answer. They have asked us to solve it. When they say solve it, they're asking us to find the value of x. Moving on to the next question. Question number 19. Logarithm of x to the base 10,000 equal to minus 1 by 4. What we'll do is the given logarithm form, we'll change it to exponential form. So we get 10,000 to the power minus 1 by 4 equal to x, because we have to find the value of x. This becomes easier. Now we have raised to the power minus 1 by 4. That means fourth root but negative. Okay, we'll not take reciprocal. What we'll do is this 10,000, we'll write it as something to the power 4. We have 4 zeros, so it is 10 to the power 4. You can just check in the calculator. 10 to the power 4 is 10,000. Raised to the power minus 1 by 4 as it is equal to x. 4 and 4 goes off. 10 to the power minus 1 is equal to x. So this was a question of directly converting logarithm form to exponential form. After that, it is simplification like how we did it in indices. Moving on to the next question, question number 20. We have log, I'll write that down, 2a minus 3b. Okay, everything is inside logarithm. Very good, equal to log a minus log b. Here it is not. So right hand side it is not inside logarithm, but we can simplify it. Left hand side I will write as it is. Right hand side log a minus log b can be written as log a by b. Correct? Now everything is in inside logarithm. So we will take antilog both sides. So we have 2a minus 3b equal to a divided by b. We have to solve for a. So we'll get a on one side. Okay. But before that, we may have to cross multiply b to the left hand side. So we have 2ab minus 3b square equal to a. Get a on one side. We have 2ab minus a, when we brought from right hand side to left hand side, equal to, it was minus 3b square, it becomes 3b square, minus sign goes off. We have to solve for a, so a is outside, that is factorization. 2b minus 1 is equal to 3b square. A is equal to 3b square divided by 2b minus 1. 3b square divided by 2b minus 1, which is there in option A. Option A is the right answer. What have we done over here? Like we have done before, we try to bring everything inside logarithm such that we can take antilog. After we took antilog, it has got nothing to do with logarithm. We solved algebraic equation, we solved for a, cross multiplication, factorization, and got the answer as option A. Moving on to the next question, we have 1 divided by log ABC to base AB plus 1 divided by log ABC base BC. Earlier we had base AB, now we have base BC, and if you see the third part, we have base CA, different base. So what we'll do is we'll change base. Okay, I'll rewrite using change of base rule. 1 divided by log ABC divided by log AB plus 1 divided by log ABC by log BC plus 1 divided by log ABC by log AC. Now we have fraction in the denominator. What do? We need to take reciprocal, it goes to the numerator. So we get log AB divided by log ABC plus log BC divided by log ABC. So we are getting same denominator, log AC divided by log A, B and C. Common denominator, LCM, common again, log ABC only. So we get log AB plus log BC plus log AC. When we have to add terms inside logarithm, we just have to multiply those terms and take logarithm at once. So equal to log of AB into BC into AC, whole divided by log ABC. In order to multiply, we just have to count how many times we have A. So we have log A square, B square, B is repeated twice, C square divided by log ABC. A square, B square, C square, can it be written as log ABC whole square? Correct? Only for ABC square it is log ABC square, okay, not for the entire logarithm, divided by log ABC. Get 2 outside, we have log ABC divided by log ABC. Everything cancels other than 2 and my answer is 2. Answer is equal to 2. So what did we do over here? We changed the base, then we took reciprocal. We have common denominator, we just have to add the numerator. We came to a very simple value at the end. Okay, so we had A square, B square, C square, which can be written as ABC square. 2 came outside. 2 log ABC divided by log ABC cancels. Only 2 remains. Answer is C. Moving on to the next question. Value of log 8 is there to the base 3. So I'll rewrite it as divided by log 3. I'm directly changing the base. All divided by log 16 is there. Log 16 to the base 9 divided by log 9 into log 10 to the base 4 is there. So divided by log 4. I've just written everything by changing the base. Now what I'll do is wherever I know I have perfect numbers, I will write them into exponential form. So this is equal to log 8. What is log 8 equal to? Log 2 to the power 3 divided by log 3 as it is, all divided by 16 log 2 to the power 4 divided by log 3 to the power 2, correct, into log 10 as it is divided by log 2 can be written as log 2 to the power 2. Further, the exponential form, I will bring the power outside logarithm. I'll continue here. I get 3 times log 2 divided by log 3, all divided by 4 times log 2. Multiplication is there. So, into log 10 divided by log 3 is there to the power 2. So, I get 2 log 3 into 2 log 2. Correct? Now I'll try to simplify this. I'll change the color. I'll try to cancel off the same things. We have 2 into 2 over here in the denominator, and we have 4 over here. That cancels. Correct? Okay. Next, we can cancel log 2 and log 2 in the numerator and denominator of the main denominator. Okay. Then I can also cancel log 3, which was there in the denominator of main numerator, with the log 3 of denominator of main denominator. What remains now? 3 log 2 remains, divided by log 10. This is all that remains. Look at the options. Okay, I need to apply change of base rule. We have 3 log 2 to the base 10, which is option A. Option A is the right answer for question number 22. This is the simplification. Which other method we could have used to solve? We could have used the calculator method, log 8 by log 3, log 16 by log 9, and log 10 by log 4. Simplify further, you'll get the answer. But you cannot stop over there. After you get the answer, you need to also simplify the options and get the answer the same way. So after you do all of that, you will get the right answer. Okay. Question number 22 is done. We'll move on to the next question. Question number 23. We have log of log of log x to the base 2 to the base 3 to the base 2 equal to 1. Okay, we'll go a little slow over here. Now, when we have logarithm form to exponential form, how do we convert logarithm form to exponential form? Base of logarithm becomes base of exponential form. The answer of the logarithm that we have taken goes to the power. And what is there inside logarithm becomes the answer under exponential form. So I am highlighting now this part. What is there inside square bracket? This much part. Okay. Now this is the answer for what? I'll rewrite that. Log of log x to the base 2 to the base 3 is equal to, what is it equal to? Base of logarithm is 2. Answer of logarithm goes to power. 2 to the power 1 is 2 only. Correct? Okay. Now in the next step, I will highlight this part. I'll highlight this part. Okay. Where should this go? This is equal to log x to the base 2 is equal to, now what is the base? Base is equal to 3, correct? Base is equal to 3. I'll highlight that part also. Now this base is equal to 3. Now this should go to the power. Okay, we already have 2 to the power 1, which is equal to 2. 2 to the power 1, which is equal to 2. Now 3 to the power 2 is how much? I'll write that as well. I'll repeat one step. Okay, 3 to the power 2 is 9. Further, if I have to write it in exponential form, 2 to the power 9 base is 2 to the power 9 is equal to x, implies x is equal to 2 to the power 9 is 512. 512. You can just check by substituting 512 and solving it like we solved in other problems step by step. You will get left hand side equal to right hand side. Otherwise, you have to move it to exponential form step by step. First take from the outermost one outside the bracket. You get the answer of the first logarithm, and then you move closer and closer towards the last part of the logarithm, the last term, and then you'll get the answer. I hope that's clear. Moving on to the next question, question number 24. If log of x square plus x to the base 4 minus log x plus 1 to the base 4 equal to 2. Okay. We have difference of two logarithms. So we will write it as logarithm of x square plus x divided by x plus 1 to the base 4 equal to 2. What have I done? I have taken log m minus log n is equal to log m by n. Correct? Okay. What next now? We will convert this to exponential form. How to convert this to exponential form? Remember this answer. This should be the answer when we take base to the power answer of logarithm. So I can write, now I'm writing it in exponential form. I can write 4 to the power 2 is equal to x square plus x by x plus 1. Logarithm has gone off. This is what we do when we have one logarithm. If you have two logarithms, it's easier, right? We just take anti-log on both sides. But when you have one logarithm, we always express it as exponential form to make it easier. 4 square is 16, correct? Okay. What remains on the other side? X square plus x. We can get x outside the bracket. X plus 1 whole divided by x plus 1. X plus 1, x plus 1 cancels. Oh, we got the answer much quicker than I expected. Answer is 16. So here log m plus log n is used. After that exponential form is used and then just the simplification. Answer is equal to 16. Moving on to the next question. Log y to the base x is equal to 100. Just write that down. Log y to the base x is equal to 100. We also have log x to the base 2 is equal to 10. I have to solve the value of y. Correct? Okay. I'll change it to exponential form. Okay. What do I get? X to the power 100 is equal to y. X to the power 100 is equal to y. Is that option there? Not there. Further, I will even write the second one in exponential form. Here we have 2 to the power 10 equal to x. Okay. Now wherever there is x, I will have to substitute this value. So substituting x is equal to 2 to the power 10, I get 2 to the power 10 whole to the power 100 is equal to y. Using laws of indices, I know I can multiply this. So I get 2 to the power 1000 is equal to y. Do we have that option? Yes, we do. 2 to the power 1000 is equal to y. That is question number 25. Again, we have used logarithm to exponential form to get the answer. First, I got it for y equal to in terms of x, x to the power 100. Then I realized there is no x in the option. Okay, then the second term which is given there also, when I convert it to exponential form, I got x equal to 2 to the power 10. Now we are just merging to get the answer. Y is equal to 2 to the power 1000. Couple of more questions remaining. We are almost at the end of this chapter. Okay, question number 26. Which of the following is true? If I roughly see this, it looks like we have different denominator on the left hand side. Right hand side we have denominator as ABC. Even on the left hand side, if you closely see, we have AB, BC, AC. I know if I take LCM, I'll get ABC. Okay, so we'll start with that. We'll see where we reach. Okay, first we get ABC as the denominator for the left hand side. AB is already there here. See, I'm highlighting AB is already there. So C is missing, plus BC is already there. A is missing. AC is already there. B is missing. Equal to 1 by ABC. I'll just rearrange the letters A, B and C. A plus B plus C as it is. Whole divided by ABC. I could have skipped this step by just cancelling. Yes, now I'll do that. I've cancelled ABC on either sides in the denominator. So you just have A plus B plus C equal to 1. Looking at the option, do I have this? No, but everything is in terms of log. So I'll take log on both sides. Take log both sides. What do I get? Logarithm of A plus B plus C is equal to log 1. How much is log 1 equal to? Logarithm of 1 to any base is equal to 0. Is this option there? Yes, it is there as option D. Option D is the right answer. So this is the first problem where we had to take log on both sides. So it was a normal solution up till there, up till that part where we solved it like a algebraic equation. After that, once we took log, we had to use the properties that we have learned in logarithm. Next question, last question in this particular unit. And remember, this is the last unit of this particular chapter. So it's the last question of this particular chapter. X is equal to 1 plus log QR to the base P. Y is given to be 1 plus log RP to the base Q. And Z is given to be 1 plus log PQ to the base R. We have to find the value of 1 by X, 1 by Y and 1 by Z. So the value of X is given, value of Y is given, value of Z is given. Requirement is 1 by X, 1 by Y, 1 by Z. So I have to substitute the values over there. But the way the values of X, Y and Z are given are not straightforward. It is 1 plus something with a different log, base and all of that. So what we'll do is we'll simplify the value of X. So X is equal to 1 plus log QR to the base P, correct? Okay, we can simplify this 1 plus log QR to the base P is there, so divided by log P, correct? Now further, we can take LCM. What is the common denominator? Log P. We get log P plus log QR. We have log M plus log N. What is log M plus log N? Log Mn. So we get log PQR divided by log P. Now this is just the value of X. See, directly if I substitute it also, we can do it, but then we may solve it in a bigger equation. The calculations get complex. Instead of that, I thought first we'll get the value of X, then the value of Y, then the value of Z, then we will substitute. Okay. So next we'll get the value of Y. Y is equal to 1 plus log, we have RP divided by Q, right? Okay. I'll expand it. Log RP divided by log Q equal to LCM. Now same steps what we just did. Log Q cross multiply log Q plus log RP. Now log M plus log N wala formula. Log PQR divided by log Q. So we now got the value of Y. Now we need the value of Z. You must have guessed the value by now, looking at how the solution is going. Okay. Anyways, I will still write 1 plus log PQ to the base R equal to 1 plus log PQ divided by log R, that is change of base. Next LCM log R cross multiply log R plus log PQ equal to now log M plus log N, same to same with this 3 times log PQR, but this time denominator is log R. This much is done. So we have X value, we have Y value, we have Z value. Now we have to find the value of 1 by X, 1 by Y and 1 by Z. We have to substitute values in 1 by X plus 1 by Y plus 1 by Z. Okay, we'll substitute 1 divided by what is X equal to? X is equal to log PQR divided by log P, correct? Next, plus what is Y equal to? Log PQR divided by log Q. What is Z equal to? 1 divided by log PQR divided by log R. What next? We have to take reciprocal, because in the denominator there is fraction. We will have to take reciprocal. Continuing the solution from the previous page, I get log P by log PQR plus log Q by log PQR plus log R by log PQR. We have same denominator. So common denominator, we have log PQR. What did I do in the previous step? It was just the reciprocal. The denominator of the denominator came to the numerator of the numerator. Okay, what remains over here? Log P plus log Q plus log R. Now if I have to add log M plus log N, it becomes log PQR. Denominator is also log PQR. Cancels equal to 1. 1 is the answer. 1 means you're single, 1 means it is complete. And we have completed this unit. We have completed this chapter. Before that, we'll mark the answer over there. Okay? And the answer is equal to 1. Done. Okay, with that we have completed logarithms. I hope it was clear. I hope you have understood all the concepts that are there under logarithm. Okay, we have finished the first chapter as well. We have finished ratios, we have finished proportions, indices and logarithms. First chapter is complete. Second chapter we will have about equations, left hand side, right hand side, more on it in that particular chapter. Thank you so much for watching.